Okay, section 4.5, indeterminate forms and L'Hopital's rule. So going way back to one of the first things we did, we talked about limits. And the first thing you were supposed to do with a limit was you were just supposed to plug that number in and see what's happening. And in this case, if we plug in 3, I'm going to get 0 over 0. And we learned long ago that 0 over 0 as a limit was indeterminate, which told you that it just meant nothing, that there is no conclusion about the limit, except that substitution didn't work. And you have to try something else. So way back when, the something else in this case was that we factored. And the x minus 3's cancel. And we substitute in what was left. And we got 6. And then the same thing here, you would substitute, and that gave me 0 over 0, no conclusion. And then we looked at some graphs and whatnot, and you were just told to memorize that the limit as x goes to 0 of sine x over x was 1. We didn't actually fundamentally prove it, just told you to memorize that. Then we did some other trig limits where we had to do lots of manipulation to, we'd multiply by things, break things apart, and do some manipulation to come up with some other trig limits. And no one ever likes that. And when we were doing that, I said, for those of you that have had calculus before, you may not use L'Hopital's rule till we get there. Because L'Hopital's rule does simplify a lot of these limits that are 0 over 0. But you needed the derivative in order to use L'Hopital's rule. Well, now we have the derivative, so we can use L'Hopital's rule. And so down here, now we'll zoom in a little bit so you can actually read it a little bit more. 0 over 0 as a limit is meaningless. We call 0 over 0 as a limit an indeterminate form. One way to sometimes evaluate limits of the form 0 over 0 is to use L'Hopital's rule. But as we know, sometimes you don't have to use L'Hopital's rule. Factoring and canceling worked just fine there. But when there doesn't seem to be an obvious way to get around that 0 over 0, we can do this thing called L'Hopital's rule. And it's down here at the bottom, L'Hopital's rule. Suppose f of a equals g of a equals 0, and that f and g are differentiable on an open interval containing I containing a, and that g prime of a is not 0 on I if x is not equal to a. Okay, that's the whole mathematician's way of saying, suppose I got 0 over 0. That's most of that. F of a equals g of a equals 0. It says, suppose I have 0 over 0. Then what L'Hopital's rule is saying is that you can replace that limit with a limit that will have an equivalent value by taking the derivative of the numerator over the derivative of the denominator. Not a quotient rule, but the derivative of the numerator over the derivative of the denominator. And then it says, assuming the equation on the right, assuming the limit on the right exists. And so these will have equivalent answers. And the hope is that by taking the derivative, that you then come up with a new limit that you can work with. So let's practice L'Hopital's rule. You still always start by substitution, because L'Hopital's rule is only applicable for now on 0 over 0. If you use L'Hopital's rule on a problem that it's not applicable on, you will get a wrong answer. So you always start substituting. Now here I just wrote this 2 ways. Sometimes you'll see that argument in parentheses, sometimes you won't. But we start by substitution. And so the limit as x goes to 0 of 2, it's not legible. The limit as x goes to 0 of 2 tan inverse of 3x squared over 7x squared. Try substitution first. So that's going to be tan inverse of 0 times 0 over 0, which is going to be 0. And then you have to ask yourself what tan inverse of 0 is. So tan inverse of 0, what angle on negative pi over 2 to pi over 2 has a tangent of 0? Now some of you may know your values really well, but tangent equals 0 would imply that sine over cosine equals 0. And a fraction is only 0 when its numerator is 0. And that's just horrible, horrible, horrible notation. Don't copy me, but it's what all of us are thinking. Horrible, horrible notation because I wrote down trig functions without arguments, and trig functions should always have arguments. Well, sine is 0, and it's actually bothering me so much, I'm going to put x's in there. That's how much it's bothering me. Tan x equals 0, sine x over cosine x equals 0, sine x equals 0. And that happens at x equals 0. So tan inverse of 0 is 0. Taking that back up there, we've got 0 over 0, indeterminate. We can use L'Hopital. LH is always going to stand for L'Hopital. But you have to substitute first to see if L'Hopital's applies. Now, you don't have to be this explicit and write it all out. You can think it and then go to L'Hopital's rule, but you do have to do the substitution first to make sure that L'Hopital's rule is applicable. Now, let's do a little recall here first before we actually do L'Hopital's rule, because it's been a long time since we've seen the derivative of tan inverse. The derivative with respect to u of tan inverse of u was 1 over 1 plus u squared du dx. And in this problem, u is going to be 3x squared. So let's do this problem. The limit as x goes to 0 of 2 tan inverse of 3x squared over 7x squared. We can make our life a little easier. Remember some of our limit rules, that coefficients can be factored out. So I'm going to just factor out that 7 and the 2. That's fine. And now using L'Hopital's rule. And any time I use L'Hopital's rule, I'm going to put an L, comma, H over the equal sign. That way you know what I'm doing. Derivative of the numerator. So using this formula right here. So 1 over u squared. But u squared is 3x squared. So u is 3x squared. So using that formula, 1 over u squared, but replace the u with 3x squared. Then du dx, 6x, over the denominator, 2x. And now we simplify. Don't try to work with it looking like that. Simplify. Go out a little bit. Bring that down a little bit. Actually, that's good. Simplify. So we get 2 7s times the limit as x goes to 0, and I'm going to show every simplification step I can think of. So that's 6x over 1 plus 9x to the 4th over 2x. And continue to simplify, so that's 6x over 1 plus 9x to the 4th. And then just showing every step, because algebra is sometimes an issue. Remember, fractions are nothing but division. Here was my numerator, here's my denominator. Here was my original numerator, here's my original denominator. There's my numerator, there's my denominator. So we have all of that divided by 2x. Fractions are nothing but division. And again, showing every detail. Think of that as 2x over 1. That's 2/7. The limit as x goes to 0. 6x over 1 plus 9x to the 4th times 1 over 2x. We get some nice simplification now. So it's the limit as x goes to 0 of 3 over 1 plus 9x to the 4th. That the 2x and the 6x cancel, leaving 3. And finally, I can do that limit by substitution. And so that's 2/7 times 3 over 1 plus 9 times 0 to the 4th. And what that is, 6/7. And we've done the first one by L'Hopital's rule. Okay, we're just going to practice a little bit. Then we'll make it a little bit better. We'll extend it. Again, substitute first. L'Hopital's rule right at this moment is only applicable for 0 over 0. I'm going to make that look a little better before we go on. That looks a little better. And it still looks horrible, doesn't it? Got horrible, horrible handwriting. Kind of feel sorry for you guys. But you have to look at this. That's a little bit better, I guess. And I don't know why I'm fussing around so much making the handwriting look good. Okay, there we go. Substitute first. So we get 0 minus sine of 0 over 0 times tangent of 0. So that's going to be 0 minus 0 over 0 times 0, 0 over 0. Use L'Hopital. LH, L'Hopital. And like I said, every time I do L'Hopital, I'm going to write a little LH over the equal sign. Again, you don't have to show me this step right here where you substitute, but you need to think about it, because if you use L'Hopital's when it's not applicable, you will get the wrong answer. So doing L'Hopital's, I've got the limit as x goes to 0. That's going to be 1 minus cosine x. Product rule down here. Plane first, derivative of the second, plus plane second, derivative of the first. And just making that look a little prettier. And let's substitute now. And so I'm going to get 1 minus cosine 0 over 0 times secant of 0 squared plus tangent of 0. So that's going to be 1 minus 1 over 0 times 0. Now, secant of 0 is not 0. Secant of 0 is 1. 1 squared plus 0. I've got 0 over 0. And so all that tells me, it doesn't tell me anything has gone wrong. It just tells me to try L'Hopital again. As long as you have 0 over 0, you can continue to use L'Hopital. So that's what we will do on the next video.